Okay, on number 16, so they tell us in the given that from here to here is the same thing as from here to P to N. And we're supposed to show that these two things are equal. So this trick, we've done a lot of congruent triangle stuff, but this kind of proof would have been, we would have done on an earlier. So we've never seen one quite like this, so this will be a little bit new for us. Guess what line 1 is? Yeah. Now, if you look in the book, they wrote a lot of stuff for the given, but this is kind of the important part. Those two arcs were the same. Like, given that this circle exists, whatever. I'm just going to write that part down. That's fine if you just write that part down. MO and PN are congruent. All right. So the next thing I'm going to say is that MO is the same thing as MP plus PO. Arc MO is, well, the measurement. So they put a little M right there to say the measurement of the arc is equal to MP plus the measurement of MP plus PO. Okay, why do they put the little measurement, the little M? Because when you put the little M, it's talking about a number. The arcs themselves are not numbers, but if you put the measurement of the arc, then it is a number, so you can't actually add those together. Okay, does that make sense? This little arc plus this little arc adds up to the big arc. Okay, if I was here in like chapter 2, we would have talked about something called the segment addition postulate, which is similar to this, but little segment plus little segment equals big segment. Okay, so this is called the arc addition postulate. You guys remember what postulate means? It means a statement that's kind of so basic you just have to assume it. You can't prove it. Like 2 plus 2 is 4. It's kind of hard to prove. It's just something you just assume is true. So it's kind of like the building blocks of everything else that we do prove. Similarly, I'm going to say that NO plus OP is equal to PN. So PN, this other one, is equal to NO plus OP. Or I guess I'll call it PO again. I'm put that on line 2 because that's also arc addition postulate. So say myself, I'm going to call that step 2 still. Okay, here comes the magic trick. So we got MO and PN are the same, right? And if MO is all this stuff and PN is all this stuff, then what can I say about that? Okay, if these two are the same, then all this stuff must be the same as all this stuff, right? You guys know what that?
MP equals NO.
Do you guys know what that trick is called? Like if these two are the same and these two are the same, it's kind of like you can put this right there. Substitution, yeah, substitution. It's a major trick. All right. So on line 3, I'm going to say that all this stuff must be equal to all this stuff. So I'm just going to kind of write that all down. Usually I don't put the little M symbol. Maybe I'm kind of regretting having put that now, but oh well.
That means that MP is the same as NO.
Huh?
Does that mean that MP is the same as NO?
Yeah, but we got to say it a certain way. you guys can see that MP plus PO is the same thing as NO plus PO. So therefore, we're trying to say MP and NO are the same thing. That's what we're trying to get to. So I kind of need to get rid of these POs. Okay, yeah, so what the book usually does, yeah, you subtract it from both sides. Like an algebra principle, you can subtract the same value on both sides. So usually what the book does is they write something like this. Ah, crud. Okay, hold on just a second. We'll finish this up. They call that the reflexive property. See how I lined it up nice? Whoops. I lined it up nice and neat. And then they subtract it. From both sides. They don't show it exactly, but that's what they do. They subtract it from both sides to get your answer. What's it called when you subtract the same value from both sides? It's called the addition property of equality. Not something we usually reference. Addition property of equality. Voila. Alright. That's it.
Mine looks weird because I've been moved pages by and subtracted, so like I do it right under.